So we want to take a look at the triangle midsegment theorem. So first thing we want to do is define what is a triangle midsegment. So a midsegment of a triangle is going to be a segment, where the endpoints are the midpoints of two sides of a triangle. So we take the midpoints of two sides and we connect them. So if I'm thinking, I'm just going to doodle one real quick here. If this is a triangle and I take the midpoint of two sides, if I connect them, that's my midsegment right there. Okay, so we have a couple of useful properties about midsegments. So the first thing is that a midsegment of a triangle is parallel to the side that it does not intersect. Okay, so if I was to mark that on this figure, I would mark that this midsegment and that side there that it doesn't touch, those are parallel. And it is exactly half of its length. Okay. So I can label this real quick. We can say this is A, B, C, D, E. So we could say that BD is equal to half of AE. Okay, so what can we do with this? So we can draw some conclusions here off of these various figures. So first off, if I have that AB is congruent to BC, that tells me that B is a midpoint. And if CD is congruent to DE, then D is also a midpoint. So that means that BD is a midsegment. That's the first thing we know. Then we also know that BD, or DB, is parallel to AE, right? We can even mark that on there. They're parallel. And I can find the length of BD because it should be half of the side of the triangle that it is parallel to. So BD should be 12. Okay. So let's take a look at another example here. Okay. So we're looking at listing our parallel segments in this triangle right here. So our first set of parallel segments are going to be MO. It's going to be parallel to LP, so that other side of the triangle. Then we're going to have that NP is parallel to MQ. And then we also know that NL is parallel to OQ. So NL is parallel to OQ. So those are all of our parallel segments, because we know that those segments inside of our larger triangle are midsegments. And we know that because if we look at the measurements, M, Q, and O are midpoints. So it's asking us to find the perimeter of MOQ. So the first thing we want to do is make sure that we're finding MOQ. So that is this triangle on the inside. So to find the perimeter, I need to find the side lengths of that triangle. So first off, if I look at, I don't want my highlighter there. If I look at LN, the overall length of that side is 8, which means its parallel midsegment there is half that length, or 4. And we can just go around this triangle doing the same thing. So NP is 10, which means the midsegment parallel to it will have a length of 5. And then lastly, LP, total length is 12, which means the midsegment that it's parallel to will have a length of 6. So our perimeter here would be 6 plus 5 plus 4, which would be 15. So we're going to take a moment and talk about the angles in a triangle where we have all of the midsegments. So we're going to come back to this problem down here we're just going to slide off to another page for a moment and see how we can use that to find some angle measurements. All right, so I'm going to go ahead and erase all the marks that I made so we can fill this in a little bit more accurately. Okay, so it says we're given that the measurement of angle N is 72 degrees. The measurement of angle L is 58 degrees, and we want to find all the rest of them. Instead of putting it on in that little box there, though, with the measurements, I'm just going to label my figure. So what we saw from the previous slide was that all of our bottom left angles in these three outer triangles are congruent. So that means if angle L is 58 degrees, then angle NMO will also be 58, and so will angle OQP. Okay, then all of our top angles were congruent. So if angle N is 72, then angle LMQ is also 72, and angle POQ is also 72. Now at this point, we can just use our triangle angle sum theorem to find the missing angle. So in this triangle, we would have a missing angle of 50 degrees, and all the bottom rights should be the same, 50 degrees, 50 degrees. Okay. Now we can just fill in our missing angle here using the fact that we know that a straight angle has 180 degrees. So this angle right here, in order to get 180 degrees, would give us an angle measurement of 58. Okay, and then we would need an angle measurement of 72 and an angle measurement of 50 for that one. Okay, and now we've filled in all the angle measurements in that triangle. So I want to take a look at this triangle. We're going to assume all of these segments in here are mid-segments. So all of these segments in the center, inside of the triangle, are mid-segments. And I want to look at angle relationships within this triangle. So I'm going to look at parallel lines for the most part here. So I'm first going to look at this set of parallel lines. So we know that parallel lines, when cut by a transversal, create our alternate interior, alternate exterior, corresponding angles, things like that. So we have those relationships in this situation. So what I'm going to do is I'm going to highlight some of these angles that are congruent to each other. So because I have these two parallel lines here, so we have parallel lines, I have a couple of congruent angles. So I know that this angle right here is going to be congruent to this angle because they are corresponding angles when we're looking at this transversal, right, this side of the triangle, and the two parallel lines that I have highlighted in green. These guys are going to be corresponding angles. Similarly, over here, we have another set of corresponding angles, and I'm going to mark them with different congruencies because I found them off of a different transversal, so they're not necessarily congruent to the other two. In fact, typically they will not be. Okay, so that's all we're going to pull from those, but we have to remember we have other sets of parallel sides. So we have this midsegment is parallel to this side of our triangle, and we can find some congruent angles using that. So first thing, I can say, okay, well, this angle right here is going to be congruent to this angle up here. And I'm going to give those 3 tick marks because they don't line up with any of our other angles. Okay. But then I also know that this angle down here corresponds to this angle right here, which is already a single tick mark angle. So I'm going to label it with a single tick mark as well. So we're starting to see some common congruencies here. Okay, we have one more set of parallel sides that we can work with transversals on. Okay, so let's get some corresponding angles from this. So this top angle here would correspond to this 3 tick mark angle there. So I'm going to add its 3 tick marks there. Okay, and now we have quite a few things matched up, except this angle down here corresponds to this double tick mark angle over here as well. Now we have kind of these three, so we have 1, 2, 3 triangles around, and we have this fourth triangle in here that we don't quite have congruencies marked on yet. But what we're going to use is supplemental angles. So I know I have some linear pairs, I guess linear triplets might be a better word, going on right here. And I know that 3 angles in a triangle add up to 180 degrees. So a single tick mark plus a double tick mark plus a triple tick mark make 180 degrees in one of our triangles. So either triangle 1, 2, or 3. So then when I go to this triangle 4 here in the middle, if I have this sort of 180 degrees here, I know that this angle right here has to be a single tick mark angle, okay, because we already have a double and a triple. So then over here, that needs to be one of my double tick marks, and then this guy needs to be my triple. So it's almost like we flipped one of the 1, 2, and 3 triangles around. So we'll go ahead and draw this in a little bit more of a concise picture off to the side where we don't have so many colors. But the general pattern is going to be that we have 3 triangles kind of round the outside, and they're going to follow a very specific pattern. So the bottom right angles are all going to be congruent to each other. The bottom left angles are all going to be congruent to each other. And then the top angles are all going to be congruent to each other. And then in the middle, so that fourth triangle, we're just going to fill in our missing ones. So if we have a double and a triple, then we have a single. Single and a triple, then we have a double. Single and a double, then we have a triple tick mark. So this is going to be kind of the consistent congruency pattern for all of our triangles when we have all 3 midsegments. So let's go back to the previous example.